Yeah, hi Shayok. So today we have Shayok, a computer vision expert with us. He will be walking us through different use cases of computer vision. How do we apply data-centric learning using deep learning, data-centric training or learning for computer vision with specific to deep learning. So let me introduce Shayok. It's my pleasure to have you here, and it's also a pleasure for the entire community of Google developer groups and TensorFlow to hear out from you what are the challenges you have faced and how did you apply those in your daily training tasks or applying it to new mechanisms of training, because I've seen a lot of papers you have written, a lot of conferences you have attended, and you have been speaker. So let me formally introduce Sayak Paul works in Cartered as a machine learning engineer. He is an expert in the field of computer vision, well known as an author, speaker at various developer meetups and international conferences. He is an active contributor to TensorFlow Hub and Keras. For his community contributions and innovative projects, the Intel Software Innovator Program recognized him as one of the top innovators in 2019. For his open source contributions, he has also been awarded Google Open Source Peer Bonus Award in 2020 and 2021. He is primarily interested in image recognition and generation tasks. He is also interested in other areas of deep learning such as model optimization, semi-supervision, self-supervision, and model robustness. He has also a good amount of experience in implementing research ideas, sometimes incorporating them in practical applications and communicating his implementation details through lucid writings. So, a very warm welcome to you, Shayok, and it's over to you. So, let's
Yeah,
walk through
thanks
some of
for
the topics. Yeah, please go
thanks
ahead.
for inviting me to this wonderful platform. It's really a pleasure being here, and sorry that we couldn't do this sort of in a offline manner because of the pandemic. But yeah, the life must go on, the show must go on, right? Uh, yeah, coming to the problems that I have faced and related to different data centric approaches that you just mentioned. I would like to first cite one of the competitions I took part in earlier 2021, back when I was working at PyMeth Search. So the competition was hosted at CVPR 2020, and the problem was to come up with an image classification model that can detect different scenes. So the real life scenario is when we take, photographs with our mobile cameras, the idea is to organize them in terms of different scene categories and so on, to in order to help the users to better organize their, photo galleries in a way that is optimized for local image search. So that was the problem statement, relevant to real world use cases. So yeah, should I share a link
Yeah, sure,
for that?
sure, sure.
Yeah.
Yeah, you can put it in the StreamYard so the audience can directly view it.
I guess I won't be able to display it as a banner, but I am happy to give it to you via chat so that you can
Mhm.
display it as a banner, because I am not one of the admins. So
Okay,
yeah,
sure.
let me share the link first so that they have better reference. This is here. Yeah. So this is the technical report where we have sort of detailed our approach. It contains approaches from the other winning teams as well. So for better context, our solution was one of the top solutions among others. So we were competing against teams from ByteDance and so on. So for more context, ByteDance is the organization that primarily works on TikTok and other computer vision based applications and so on. So uh, yeah, so these particular technical report contains top 10 approaches, and if I am not wrong, then ours is the only one that incorporates semi-supervised learning and data centric approaches in a very systematic manner. So yeah, that's the context. And regarding code open source implementation, I think our technical specifications are sort of developer friendly, and They can be easily followed by machine learning practitioners in case they want to implement some of the ideas that we have presented. But in any case, we do not have any concrete plans to open source the implementation as of yet. But in any case, they can always reach out to the team members, and we are always happy to answer any questions. Now, coming to the solution approaches and the problem that we faced. So here it goes. So we were provided with a data set of merely 10 to 20,000 images of
Mm-hmm.
different scenes, labeled as different categories, like this is a landscape scene, this is a portrait scene, this is a live action scene, and so on. So from there, we were also provided with a couple of unlabeled examples, unlabeled images to be precise, uh, which which served as the test set for the competition, right? So that's how most of the competition goes. Like you have
Mm-hmm.
you have a particular amount of labeled examples in case we are competing in a supervised problem, and then you have a couple of unlabeled examples on which your solution will be evaluated, right? Now, the organizers also had an internal test set, which is also common in most of the benchmark competitions. But yeah, so that's there. I mean, that's the data related details. Now, given that we already had access to unlabeled data, we thought maybe we could incorporate that unlabeled data in some ways, because we had benchmarked many state of the art image classification models using different techniques like transfer
Mm-hmm.
learning and so on. We also trained a model on all the labeled examples that we had from scratch, and of course the fine-tuned model performed really good because the pre-trained model that we used had some overlap with the kind of data that we were using. So in particular, we fine-tuned the model. We just did not compute the frozen representations and le- uh, learned a classifier on top of that. We fine-tuned the pre-trained representations that the pre-trained models already had. So that, I mean, training from scratch did not give us good results as expected. And also, we noticed that when we fine tuned the pre trained models on all the labeled examples that we were provided with, did not also perform to our expectations. Now we asked ourselves that, hey, we already have access to a specific set of unlabeled examples. Now, is there
Mm-hmm.
any way we could incorporate that? But there are certain challenges here. If we end up using the unlabeled examples, how can we evaluate the model in a systematic manner? Because when we do evaluate our model, most of the times we either do cross validation, or we keep a separate held out sort of validation set or a test set that is sort of untouched. We cannot, that is a
Mm-hmm.
canonical set, and we cannot
Unbiased.
touch it.
Yeah.
Yeah. Now, also, in our investigations, we found out that all the data samples were kind of IID. They were independently and identically distributed, so there was not a problem of domain adaptation and things like that. So that indeed made our efforts a bit more streamlined and easier.
Mm-hmm.
So, upon thinking further and diving deep into the current research practices, what we did was we first pseudo labeled all the unlabeled examples that we were provided with. I mean, that incorporated, that was actually serving as our separate held out, test set, and the scores that we were receiving was from the platform that the competition organizers had provided us. That was the final source of truth in terms of evaluation for us. Now, first we incorporated all that unlabeled examples in order to pseudo label them. Now we only considered the high confidence predictions, and we discarded all the examples on which the model was not feeling confident enough. And this is a classic semi-supervised techniques that's sort of popular across a wide variety of seminal semi-supervised learning papers that you will
Mm-hmm.
come across. So that was there. And then we took all the pseudo labeled examples into consideration, and we then followed the cross validation path. Now those pseudo labeled examples became a part of the main training set that we were using, and then we sort of cross validated our fine tuned models on top of that. So we did a threefold cross validation, and
Mm-hmm.
that ultimately led to the best performing models that we end up submitting to the competition organizers. Now this particular idea of using unlabeled dataset, or let's say this particular notion of using more and more data to further improve our models, came from Andrew Young. So he has been, encouraging data-centric approaches for
Purposes. Yeah.
quite a while now. Now we thought to ourselves that maybe if we could, uh, increase the amount of data that we have, we could get a performance boost. But also, we had to consider that Andrew Young had suggested that you need to also sort of increase the quality of data with which you are doing the training. Right now, how do we incorporate the quality aspect here? Because we are not domain experts, and we did not have the bandwidth to sort of manually check all the images and label them ourselves. Now that particular sort of thought became one of our challenges. How do we incorporate the quality aspect? Now we settled with only the high confidence predictions, and that served as a pretty good enough test bed for us, that the high confidence predictions from an already better trained model might be a good signal for us, and that ended up as quite a good approach for us. So that was one. And my point here is that, you know dabbling with all the state of the art approaches in image classification, transfer learning, and so on did not really,
Yes,
click.
Shayak,
Did not
there is
Yeah,
one question. Should we take that? Can you please elaborate on
yeah,
pseudo
yeah,
labeling? How is it performed? Yeah,
yeah. I mean, let me complete the earlier statement first, and
yeah,
then
sure, sure,
I'll
sure.
get back to that. So my point here is, even after dabbling with all the state of that approaches for image classification, we tried all sorts of things like crazy data augmentation, high other forms of regulations, and so on, but that did not really click for us. Just increasing the amount of training data did pretty well. Now we were wondering if we had a domain expert with us, if we could, incorporate more labeled data from the entire unlimited practically entire practically unlimited pool from internet images. We If we could incorporate some domain expertise there and incorporate a large pool of, unlabeled data, probably we could have performed even better. But yeah, we uh, left that as a future work. Now coming to the question, pseudo labeling is, in my view, one of the most simple techniques that you can do if you are interested in semi supervision. So what it does is, you first train a model on some training data, right? You then take that model, and then you use it to infer the labels on some samples that are not unlabeled. I mean, that are not labeled yet. Now what you have is, you have some predicted labels for the unlabeled examples that you already had, right? Now what you can do is, you can incorporate those pseudo labeled examples in your primary training set, and then you can learn another model on top of that, and then you can sort of keep on repeating
So,
this
yeah, so,
loop.
so what is the criteria for repetition? Means how do you choose like the thresholds and fine for fine tuning it further?
Yeah. So usually we set a manual threshold. So most of the works, at least in Vision, do set a very high confidence threshold. Like, if your if your maximum softmax predictions are below, let's say, 0.85, then you do not choose that particular example. If it's beyond that, then you end up incorporating it. Now there are all sorts of ways you can quantify the amount of uncertainty, but in our case, those uncertainty estimates did not really matter. Plain old vanilla, manual thresholding worked for us. But there are, certain approaches with which you can quantify the uncertainty estimates better and have a better sense of the thresholding scheme. Now that's one approach. The other approach is to have an adaptive kind of threshold. Like, as you are training the model on the uh, you know on the pseudo labeled data and the primary training data that you had, you can adjust the threshold. You can adjust some initial threshold with some, annealing scheme, right? Like you start off with, let's say, 0.87, then you slowly anneal that threshold and see how your performance is improving, or if it's not improving, and then you can sort of iterate on top of that. So these are like few approaches that you can take, and in order to sort of have better, initial confidence predictions for your unlabeled examples, you can incorporate ensembling approaches. Like you
Mhm.
train multiple models on your initial training set, you take their ensembles when doing the pseudo labeling part, and in order to further boost things, you can also do something like text time augmentation. It's also another form of ensembling. So yeah,
So what is that? Means
these.
what is his uniqueness?
Yeah, sure. I mean, in test time augmentation, what you essentially do is, let's say you have an unlabeled example, and you then pass it from one augmentation transform, let's say random crop. Then you pass it from, let's say, horizontal flipping, and then you pass it from another augmentation transform, let's say color jitter. Now you combine all the predictions and take their maximum, or average them out, and so on. So that is another form of ensembling, but not in a model specific way, in a sort of data specific way.
So to speak. And how do you scale? Means how do you how do you understand that this is the point that we should add more GPUs to it? Is there any benchmark that you look for the CPU utilization or memory utilization, or is it there is some standard mechanisms that this should run in these boxes, this type of cloud infrastructure?
Yeah, that's a good question. I think in terms of scaling things out, we first need to decide how many rounds of pseudo leveling we want to do, right? So in our experience, our stopping criteria was the cross validation performance. The moment we realized that the cross validation performance was getting plateaued, we stopped. Like it can be like 4 or 5 rounds of pseudo labeling, or it can be like 2 rounds of pseudo labeling. Entirely depends on how you are treating your thresholds and what's your performance benchmark that you have set to yourselves. That is one part, and the second part is, for our case, we realized that the data regime was not very large with respect to the benchmark computer vision datasets that we have these days, like ImageNet 1K or ImageNet 21K, or let's say the Open Images dataset recently released by Google. So we used cloud TPUs. We provided for free uh, through Kaggle kernel notebooks and Google Collaboratory.
Mm-hmm.
Now, in order to further boost the TPU utilizations, what we did is we first serialized all the images and their labels as TF records, and then we stored them inside a Google Cloud Storage bucket. And this is one of the requirements, in fact, that your data must be coming from a Google Cloud Storage bucket in case you are using TPUs. Now, the motivation behind serializing them as TF records was to eliminate the resizing steps, because what we do is, while loading the data, we also resize them on the fly, and then we feed it to our machine learning model, right? So what we did is, uh, we first of course scaled all the pixel values to their appropriate ranges, and then we resized all the images, and then we ended up serializing them as TF records. So that allowed us to essentially eliminate two operations from the data input pipeline. And yeah, so that's how we ensured that our TPUs were sort of utilized in the maximal possible way.
Yeah. And the how much TPUs you would need, like, so is there any benchmarks for different types of, you have handled different computer vision problems, that is the question, that is why I want to ask you this question. You have handled transfer learning, you have handled new research problems, augmentation. So
uh,
is
Again, it depends on your data regime,
data
right?
set.
If you uh, it There are a number of things that are at play here, like what is your ultimate cost budget, what is the data scale that you are operating with, and so on. So for ImageNet 1K models, you first need to for data regimes that are similar to ImageNet 1K or ImageNet 21K, where we have more than million examples, we, I think, first need to fix it on a particular compute budget that,
Mm-hmm.
yeah, we cannot go beyond this. And then we need to sort of reduce the space of available options. In my opinion, if your model does not have a lot of customizations, and if you are okay allocating a Google Cloud Storage bucket entirely for data pre-processing and artifact storage purposes, you
Mm-hmm.
should go for TPU based modeling because it's cheaper than using multiple GPUs.
Mm-hmm.
Now, there are other considerations, like if your entire data input pipeline and if your model architecture have some operations that are not yet TPU compatible because TPUs do not support all the operations that we see these days, then using TPUs is not an option, right? Because many of the augmentation libraries that we operate with, like ImageOg, or let's say, uh, so what was the name? Albumentations, libraries like that, they do not provide you with native TensorFlow ops. And having native TensorFlow ops in your entire pipeline is one of the requirements of you know making your entire pipeline TPU compatible. So if using those non-compatible operations is first and foremost, if it's very crucial for your problem statement, then you cannot use TPUs. In those cases, it's better to stick to GPUs. So, and then again, you need to sort of decide, hey, should we use 8 GPUs or should we use 4 GPUs? And in those cases as well, you need to choose the architecture of the GPUs that you are using, right? Because if your GPUs do have tensor cores, then you probably can take advantage of mixed precision training, which can reduce your overall training costs and so on.
Mm-hmm.
So these are some of the trade-off factors that I typically look for when I decide this is probably the best hardware accelerator that we might want to use in order to solve the problem.
Mm-hmm.
And
That's a
another
very great
sorry
insight.
for,
Yeah.
yeah, sorry for the interruption. Another point that I really missed out, but it's incredibly important, is if your data pipeline or your model handles dynamic input shapes, then that is also not compatible with TPUs. TPUs by default expect all the data to be reshaped to a fixed size. You cannot use dynamic shapes with TPUs, at least as of now. This behavior might well change in the future, but if your pipeline has dynamic input shapes, TPUs are a not good. TPUs are a not good fit.
Yeah. So there is a one question from Vishwas. So I don't
Mhm.
know how we can relate that to the uh, computer vision. So TensorFlow JS, what is all about, and when we want to deploy at scale. So can we do computer vision tasks with TensorFlow JS? And then, if so, how do we deploy at scale?
Uh, Again, I haven't used TensorFlow JS myself, but I
Mhm.
have seen a lot of folks using crazy computer vision stuff with TensorFlow JS. So I would suggest you look up JSON. If you just Google JSON TensorFlow JS, then you will get to know all the stuff that's related to TensorFlow JS. So Jason is a developer advocate working at Google on the TensorFlow JS team. So yeah.
Thank you so much. Hope that has helped our viewer, Vishwas. And then you have also worked on computer vision transfer learning using some of the existing models that are available. So, any challenges or any particular techniques that you would like to talk about?
So I can cite one of the recent challenges that I mean, one of the recent competitions I took part in. It was not the CVPR one. It was from it was organized by the NASA Impact team. So let me first give you the paper link, and then probably I
Yeah,
can
sure,
discuss a
sure.
bit
That
more.
will be very insightful.
Yeah, yeah. Yeah. This is the paper.
Mhm.
So what I have seen in my experience is you really need to understand what is what is the domain of your data. Is there Is there an overlap between between the data on which your models were pre-trained and the data that you currently have? I mean, the data to which you would like to, the data on which you would like to fine tune your models. If there does not exist sufficient amount of overlap, then transfer learning is not going to play well. Now, I understand that it's very hard to quantify that particular domain overlap, but in my experience, it's best to just, train two different models, one from scratch and one from a pre-trained model, and then get an immediate idea of whether or not transfer learning is going to be very crucial. So building on top of that, the competition that we took part in, the one organized by the NASA Impact team, provided us data of satellite imagery. Now, ImageNet 1K models, or let's say the state of the art models that we have these days that are open source from various large organizations like Google, Facebook, and so on, most of them operate with ImageNet 1K models, or the recent models from Google also operate on ImageNet 21K models, which are even better in some
Mhm.
aspects.
So what is this
Now,
21K? What is this 21K? Would you like to explain? Is it the
yeah,
size of the data set?
yeah, I mean, ImageNet 21K has got examples categorized into 21,000 different classes. So it's a multi-level classification problem. You do not have discrete categories for all the examples present in the dataset. You have multiple labels that are tagged to a particular example, and it has got also lots of more images than ImageNet 1K. So hence the name ImageNet 21K. So that's about ImageNet 21K. Now we realize that the satellite imagery that we were provided with does not have any overlap with the pre-trained ImageNet 1K or ImageNet 21K models.
Mm-hmm.
So instead of trying to mathematically quantify the difference between the domains, we trained very small. We trained two different versions of models on a limited subset of the data set. One where we trained the entire model from scratch, and another where we fine-tuned a pre-trained model. And yeah, that's how we sort of realized that it's very important to consider the domain overlap between two data sets on which you are trying to do the transfer learning stuff. Yeah.
Okay. That's a very detailed insight, like how do we handle transfer learning. So what are the specific challenges you have faced, and what have been you have to like resolve it at the go, like in the production systems, and or something when you prototype, when you did the first POC, you learned about something. So you want to share some of those insights with us as well.
uh, I mean, spend copious amounts of time with just the data, because leaky abstractions can get introduced in all sorts of ways when you are working in a machine learning problem, right? If you are not really familiar with the data, then things will go wrong. And if a particular thing has a possibility to go wrong, it will go wrong no matter what. And data is the first class citizen in any machine learning project. So spend like copious amounts of time with the data. Probably randomly shuffle your data set and try a particular chunk, load a particular chunk of the data, and try to manually go through if the data is consistent in different aspects. If is my data consistently labeled, is my data well distributed, is my data representative of the different attributes of the data, of the different attributes expected in my business problem, and so on. And also try to discuss your doubts with the domain expert, right? Because if you have a doubt, hey, probably this data is not represented in the right way, rather than trusting your instincts solely, it's always better to have some opinions from the domain expert to sort of solidify, okay, this is one instance where this particular data point is probably not worth including in the main training set. So as I mentioned, I mean, the the effectiveness of data visualization and data analysis before you jump onto training your models is unreasonable. And the more you familiarize yourself with the data at hand, the better you will be when debugging your machine learning model.
Yeah. So any particular domain that you would talk about? Like, did you get any chance to handle medical data like cancers? I heard a lot of things like tumor detection or federated learning, or some in some other domains. Let's talk about some anomalies which you had to detect from any particular domain data set.
Yeah, now I haven't worked in medical imaging in a professional capacity, but I can take an example from my current work, which involves a lot of text. So it's good to be into another domain that's different from computer vision. So uh, in our current data that we see, we have got a lot of different entries. I mean, it's hard for me to sort of make folks understand the differences that I'm going to mention here. So when we are crawling particular web pages from the internet, we do not have consistent HTML structures, right? Now when you are crawling web pages from the internet, most of the different website domains have their own structures. Now how do we unify that? How do we, because as I was mentioning, that having a consistency in your overall data representation is crucial. Now I also mentioned that different website domains represent their HTML structures in different ways. So how do we have a canonical HTML structure and compare all the HTML data that we have at hand and make the process very unified? So in those cases we had to reduce down all the data that we had in order to make things consistent for us. Like to give very specific examples, tables are represented in different ways across different HTML pages, right? You may see that many tables would have table rows visually present, but in many cases those visual lines are not there, right?
Mm-hmm.
Now how do we interpret these differences and sort of mathematically quantify it? Because if we are unable to quantify the difference between two HTML tables, then how can we work on a pipeline that is aimed at unifying these two HTML structures? So we had to sort of reduce the canonical HTML form to very basic things. Like if you go to google.com, you will see very basic HTML structures, right? Now we had to follow those particular web design guidelines and treat that as our mother or canonical HTML design, to which all the websites would be considered. And if they won't follow these guidelines up to a particular threshold, then we will not consider that. So this is how we ended up prototyping our first data input pipeline that mainly deals with unstructured and very noisy HTML data crawled from the open internet.
Different
So
sources. Yeah.
yeah.
Yeah, there is another question. So maybe I would like to tweak a bit. So some of best and worst practices in building the neural network architecture. Maybe you could relate to that to computer vision, which you have directly handled.
Yeah, sure. Always try with the simplest possible model first and then slowly increase the amount of complexity. Now, by that I mean is, don't immediately jump onto a very big ResNet model. Try with a ResNet 34 or ResNet 50 first, and then slowly introduce all the model parameters. And at the same time, it's also important to realize or ask yourself that is there enough number of parameters uh, that are needed to model the problem statement that I'm dealing with. Now, a very simple trick that you could incorporate in order to encertain that, okay, my model does have the sufficient number of parameters, is simply train a model without any regularization. If you are able to overfit that particular model, and by overfitting, essentially mean zero loss, then you can sort of ensured that okay, my model has got enough number of parameters to model the problem statement I'm dealing with. Now maybe I can introduce some form of regularization in order to prevent the overfitting. So it's also referred to as useful overfitting, where we sort of take a couple of batches of data and then we try to overfit our entire model on those mini batches of data. And if we are successful, then it's fine. Otherwise, we will have to sort of consider other things, maybe increase the complexity of the model and see if there are any nuances in the data in the first place. So that is definitely one of the best practices and tips I can suggest.
Yeah. So any website or any link, open source code or anything you would like to provide? Yeah.
Yeah, definitely. So this is like a central guide for debugging your machine learning models in the first place. Now the tip that I just shared is actually coming from that, and I have incorporated this like probably a million times. So that's how I'm sure that this is going to work in most of the practical problems that you will deal with.
Yeah. Thank you so much. Yeah. So, any other insights would you like to add? I don't know whether you have got this to work with image plus video, something. Not only images, but if there is any video, how did you go
Yeah,
about it?
I have a brief amount of experience of working with videos. Let me provide you the resources first, and then maybe I can talk about. This is one. This is another. So, activity recognition from live video feeds is a pretty real world problem, I would say, because the repercussions or the practicality of using action recognition in many applications is sort of very evident. Like if you're using any yoga applications, they are continuously tracking your movements, and all the signals they are receiving from your live video feeds, they need to sort of analyze that and infer in near real time to tell you that hey, your yoga pose is probably not correct and so on, right? And you need to have a continuity in between that analysis. Now it's always that's why it's always better to perform your analysis on a stream of images that is essentially a video, a sequence of continued image frames rather than doing your analysis on static images. So this is
So, how do you
exactly
manage
where,
the pipeline? So, how do you manage the pipeline? Do we only take images coming in randomly, or if it is a sequence of movies, or how do we manage the pipeline?
yeah, I mean, you so for seeding your analysis, you do not essentially take anything for seeding your analysis. Now after your sort of camera has started and a number of different image frames have started to come in, then you start performing your analysis. So the idea is to gather a sequence
The
of
data.
ordered image frames and then do your analysis on top of that. So in my experience, simplifying the video data in terms of mere image frames, because a video is nothing but a collection of ordered image frames, right? Now if we are able to do that, essentially then we can have all the benefits of sequential modeling into our picture. For example,
Mm.
we could use RNN based architectures in order to make our model aware of the sequential order present inside the images, and we could have a different image based model to sort of cater to the single images that we have in the ordered sequence. So then we of course have transformer based models that can also deal with sequences very well. So that's why I provided two links, one that deals with the sequences with an RNN based architecture and the other one that deals with a transformer based architecture.
Okay, that's insightful. And how do we know that there are still ground for improving our further model? So if you have reached say 75 to 80% accuracy, should we freeze, or still we have to look for ways that can improve the model accuracy, or is it the role of the data set that you were talking about? So we think about bringing data sets, related data sets from somewhere else, means same domain, bringing those data sets also, if that can improve the model accuracy or the performance.
Yeah, I think the first and foremost aspect would be the business problem. If 80% is a good Bayesian estimate, then yeah, settle with 80%. But you also need to continuously evaluate your models, right? I mean, it's not just specific to video models, it's specific to any machine learning model that's deployed in production. So you need to
Yeah, continuous.
continuously
Monitor
evaluate
it.
your models, see if they're performing well on data drifts and concept drifts and so on. And if they are not, then you also need to retrain your model and then again sort of iterate on top of that. So when you are doing the initial deployment, if I understand your question correctly, how do we ensure that
Yeah, this.
it's capable of handling the recent data trends, right?
Yeah.
I think again the effectiveness of having a proper training data set that is representative enough of all the recent data trends that your model will be dealing with is unreasonable. So in theory, your training data should be as representative as possible to the recent data trends
That's
that your
great.
model will be meeting with
Evaluate.
in production. Now, of course, there will be drifts in concepts, there will be drifts in data. In those cases, it's just better to sort of retrain your model on and other, on the existing training data plus the recent data that's coming in
Coming in.
your pipeline. But
Oh.
if I were a machine learning engineer that's dealing with this problem, I won't spend a minute improving the model architecture. Rather, I would bring in more data that respects the recency in the data and then take things from there.
Mhm. Yeah, that's a very good insight. Instead, we don't know how many neurons we can tweak it so that it will give
Yeah.
the increased performance. And also, since you talked about this, like this takes a huge time for training, also, right? Even if you use TPUs and GPUs, right? So, what I was wondering is, since we are also looking forward to sustainability, and that has been a great initiative for Google. So, how can we ensure that we pick the right data centers, or we minimize the training time or the heat that is dissipated by the machine learning models? So any tips or anything we should keep in mind while doing so?
While I apologize for not updating myself with the recent trends in sustainability and stuff, but I can share a few learnings that I've gathered over the years. Is in order to minimize your memory footprint, because memory footprints and other timing related footprints actually give birth to the other environmental factors that you just mentioned. I think in order to reduce the memory footprint, training with reduced precision is definitely one of the aspects that you can take into consideration. And instead of, I understand that different organizations have different privacy and regulation concerns, but in case if sustainability and reducing memory footprints are one of are some different aspects that you take into consideration, then it's probably best that you ship your model training to cloud data centers, because setting up a local hardware infrastructure stuff that respects all the sustainability efforts, or let's say that respects all the environment friendly aspects, is not an easy job. And if you do not have a dedicated team that would be dealing with that, I think it's best to ship the model training part to different cloud resources such as Google Cloud Platform or even AWS or Azure, because they already try to follow all the sustainability and environment friendly efforts already. So that's probably taken care of because they are continuously meeting with these requirements. And the other would be to try to look into optimization bits of your pipeline so that you are ensuring that your training time is not exceeding more than expected. Like oftentimes we see that because of a reduced batch size, my model training time is incredibly larger, or
Yeah,
because of a poor choice in the optimizer, my model is not converging faster than it could have.
exactly.
Like things like that. So
And early
if
stopping criteria, maybe some
yeah,
cases.
yeah,
Yeah.
absolutely. So if we can incorporate those technical bits while having a clear vision for the sustainability and environment friendly efforts, I think we can try our best to ensure that we are following
And any
those
specific,
aspects.
yeah, and any specific guidelines for specific to computer vision for being ethical, having the best practices for ethical AI, maintaining privacy. Because for
Uh,
PII, I know some of the guidelines we should follow, but for computer vision.
I think the fairness indicator stuff that Google recently released, it's a pretty good starting point for any practitioner that wants to ensure that their models are respecting all the ethical considerations and so on. So I think fairness indicators is a very practical way to assert that under these particular assumptions, my model is fairly ethical, and this is how we can quantify it. But we cannot say for sure that if my model is met with other data, my model will still be, fair in all probability. If we already know about that fact, where we are already submitting that, hey, for these considerations we know that our model is fair enough, but for these particular corner cases we are still not yet sure, but we are continuously working on that. I think it's still a good way forward than not considering these aspects at all. So yeah.
Mhm. Yeah. So you have done a lot of research, right? So anyways, we can think of like utilizing the optimizers that are available and can do something, tweak it on and leverage, so that the hyperparameter tuning is fast enough. So any guidelines do you have, or is it like we have to execute in a grid search manner or a more randomized fashion? What is that for computer vision that can help us?
Now, in most of the domains that also includes text to some extent, I think the role of hyperparameter optimization is crucial. It's not very specific to computer vision, I would say, but I am one of those folks that do not like to deal with hyperparameter tuning a lot, because I like to really trust my instincts and intuitions and then crack take a crack at defining my hyperparameter space accordingly. Now, let's say you have got only 1,000 samples, then probably having a large batch size is not going to work. Then also, if you have millions and millions of samples, then having a large enough model is definitely going to work better than having a smaller capacity model. Now, heuristics like this are developed from experience. You cannot, you know, develop this knowledge when you are just starting your machine learning journey. You need to actually work on hands-on projects in order to have a proper understanding of these different correlations, and from enough experience you can, have a mental model that would suggest, hey, for this particular scenario probably this default choice of hyperparameters is going to work well than the others. And these days we also have, sensible defaults in many of the libraries that we use, be it keras, be it pytorch, and so on. So all of those libraries come with very sensible hyperparameters to reduce our cognitive loads that
Mhm.
we spend on tweaking the hyperparameters. So my 2 cents would be to work on enough hands-on projects in order to develop an understanding of hyperparameters and their values, and in certain aspects when that's not possible, you already have the tools that can tackle hyperparameter tuning at scale. So one particular one that I would really like to mention is Vizier by Google. It's a black box optimization tool, and any black box function that we can evaluate can be optimized by Vizier at scale. It supports all sorts of stuff like distributed pre-processing, experimentation tracking, and so on. So definitely check out Vizier if you want to learn more about hyperparameter tuning at scale.
Yeah, thank you so much for sharing the link. So, Shaq, what do you suggest for budding data scientists who are entering into this field? How do they learn or get up to speed with computer vision? Because this is another field where even if I have a laptop, I cannot go and scale my problems. I can have data sets, but I cannot train. So, cloud access, I think, is one of the major hindrances if I want to self learn some of the stuffs. So, what is your advice? Means you have to work on practical projects, or where is the way to start?
Definitely, that's a good question. I think Kaggle kernels is probably one of the best places where you can immediately witness the advantages of using TPU based pipelines. Now, if you have your own private datasets, you can still upload that to Kaggle and use TPU accelerators, because internally Kaggle will host that private dataset in a Google Cloud Storage bucket, and until and unless you are making it public, it's of course not going to be publicly available to other Kagglers. So definitely, if you have lots of data, try to upload that to Kaggle as a private dataset. It has got a certain limit, but still it's usable for your learning purposes. But other than that, most of the cloud service providers do offer you free credits in order to supplement your learning. I think Google Cloud Platform provides you with $200 of credit that you can use for learning different things. Otherwise, you could also use something like Qwiklabs that provides you real-time learning experience in case you want to familiarize yourself with different hardware accelerators and want to have a better understanding of how to scale things, because scaling things, knowing about how to scale things, designing, making the right design choices when you are scaling things is one of the crucial aspects of working in practical problems, be it as a machine learning engineer, be it as a data scientist, and so on. So if you are already entering into the field, having this different skill sets under your tool belt will be incredibly helpful.
Yeah, thank you so much. So, Shahid, I think I have asked most of the questions, some of the that can be leveraged by experienced data scientists as well as the beginners. But I would also give you the ground, like you want to add some of this experiences or unique challenges that you have experienced, but we have not discussed, and that could be helpful for the audience as well.
I think the budding machine learning engineers, or even the experienced folks that deal with data primarily, need to come together and appreciate the open source efforts made by different communities, and they also should try to sort of take part in some of those open source uh, efforts being laid by different communities. For example, these days we have Hugging Face models that are entirely open sourced and available for anyone to use, right? And they come up with excellent API design practices
Mhm.
that makes it really easier for literally any software developer to try and test them out. Now, this is only being possible because of an enriched open source community. Lots of folks come together and contribute their learnings in forms of different, model architectures, different model conversion strategies, and so on. So the earlier and the more we get to the open source world, I think it's not only going to be incredible learning experiences for us, but it will also provide us with ways that has a direct impact on the entire machine learning community in general. So yeah, I mean, contribute to open source as much as you can, probably, because the amount of contributions would typically vary from person to person, but you can still write a blog post in a span of 1 year and open source it, publicly share it, and share your learning so that other folks do not have to go through the hurdles that you had
Same
faced.
same
Now,
challenges, yeah.
yeah, so in
And
that case you will, yeah, go ahead, go
yeah,
ahead.
no, 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 sure, you go ahead. I was asking something different. Go ahead,
Yeah,
please.
so in that manner you will probably be able to enhance someone else's life by providing them with some solutions that they could start off with.
Amazing, amazing. And since you have been also associated with research, writing different papers, so people who want to take it one level higher after learning the basic stuffs on computer vision, how do they go about it? How do they collaborate? How do they get to know the right set of people?
I think Twitter is a great platform to connect and see what other accomplished folks are doing. Now, for after like getting through all the fundamental stuff, you will of course get to read a lot of papers and try to pick your top 10 papers and follow all the authors of those papers, because it's highly likely that those authors will keep on improving that field, and from there you will start to develop your own research interests. And the more you dig deeper, the more you will the sooner you will start to realize, probably, hey, this could have been done in a different manner. And working on minimal implementations of your favorite research papers also help you to sort of understand the nuances and the intricacies of different methods that you are currently reading. So yeah.
Yeah, that's a very good insight. And also, I know that Shayak, you work on different competitions with NASA and other teams, right? Handling different types of images or different types of computer vision. So, if you want to anything, add anything, or we can also have a future session where we can learn more about some of the unique things or that's unique data sets that are not maybe publicly available, and you are taking part, and how you're leveraging your knowledge, experience to fine tune them and make sense and give insights to data
Yeah,
scientists.
I can give the example of the recent NASA impact stuff that I also mentioned
Yeah.
earlier. So
Mhm.
the dataset is novel. There does not exist any pre-trained models or any existing literature. But in those cases, what we find the best is try to have datasets that best closely match the provided dataset, and search for existing works that utilize that closely match dataset, and try to incorporate some of those approaches and iterate on top of that. So when you have data that is completely fresh, completely new, try to associate that with the closest possible thing, and then take things from there.
Mhm. Yeah, that's a very good example. So thank you, Shayok. Thank you for the coming here and sharing with us your real life challenge, means the challenges that you faced with computer vision. How did you groom yourself, and as well as some of the research work that you have been doing and competitions you have taken part. I think it should give freshers as well as budding data scientists who are trying to grow themselves to take this up more seriously, and then they can make a greater contribution towards open source, as you have talked about. So it's like collaborative effort, and no one alone is succeeding without the help of open source. That's the huge importance of open source that you have correctly pointed out. So thank you
Yeah,
once again for coming and joining us, and thank you. We will
yeah,
hope to host you again and learn from your great work that you have been doing. Thank you.
yeah, sure. It was a great learning experience for me as well. So thanks for
Yeah,
having me.
and
And yeah,
yeah, and some of the links we have shared, that Shayok has talked about, and it will be great if you can go through this, and it will surely help you in
yeah,
some way or the other. Thank you. Thank you.
yeah, yeah, and reach out to me with any questions. My email is always available, and you can find all of my coordinates here at this link.
Yeah, yeah.
Yeah,
Please share. Yeah. So he's very well known in the field of computer vision. Don't get feel hesitant. You can reach out to him and learn more about all stuffs, TensorFlow, Keras, computer vision. He's also a Google developer expert. He has been awarded many prizes for his community contributions. So thanks again, Shayok.
yeah, yeah, no problem. Thanks for having me. Okay,
Thanks. Thank you.
yeah, bye.
Bye.